Hello, Coach Travis here, and I've got a problem for you about linear approximations. So the question is, use a linear approximation to the square root function to about the value x is equal to 49 to estimate the square root of 50. All right, so we're going to use linear approximations to estimate the square root of 50. And so what I've got here on the right is the formula. It's the formula for a linear approximation to a function at some point or at some number. And so the question that always comes up is, what's A? What is A? Because obviously A is very important in this formula, and how do I figure out what A is? And okay, well, so there's a short answer and there's a long answer. So as usual, I'm going to give you the long answer, because the long answer is usually the best answer, actually. So the idea is that A is the number that you know, or rather it's the value that you know what happens when you put it into the function. So as an example, in this problem, the A would be equal to 49, because 49, that's a number that I know what happens when I put it into the square root function. 50 is I don't know what I get when I put 50 into the square root function. The square root of 50, all I know is it's a little bit bigger than 7. But 49, that is the thing that I have complete information about. I know exactly what I get when I put 49 into that function. So in general, if you want to use your linear approximation formula, what A is A is kind of your closest guess that you know complete information about. So like, I want the square root of 50, and I have no idea what the square root of 50 is. But I do know that, well, 50 is close to 49, and I know exactly what the square root of 49 is. And so that's what the A would be. Okay, so actually that was the short answer. I said I was going to give you the long answer, but I actually gave you the short answer. But now I'm going to completely ignore all of that, because the thing is, I hate formulas. I'm a fan of Star Wars. And I think about formulas as being like the dark side of the Force. Formulas are very tempting. Formulas are very fast. If you can memorize a formula, then you can solve certain problems very fast. So just like the dark side of the Force, it's very tempting that the path is easier, or it seems easier. But really, it's not good, because just memorizing formulas means you don't have the deep understanding that you need, and you run into problems like this. You run into, what's A? If I just memorize this formula, I don't have any idea what A is. Now, I guess you could memorize, okay, A is kind of the thing that I have the most information about. But yeah, I mean, you could do that. But again, that's just more memorization, and it's sort of meaningless. So I'm just going to erase this formula because I hate formulas. So I'm going to talk about how I would do this problem without using formulas and by really understanding what's going on. So here's the situation in a picture. So here's the square root function, and here's the point that we want to know. We know the x coordinate of this point. The x coordinate is 50, because we want to plug 50 into the square root function. And what we don't know is the y coordinate. I do not know the y coordinate. I mean, I know it's somewhere around 7, and the computer actually tells me that it's about 7.07, but actually the computer doesn't know either. This is just a decimal approximation that the computer is giving me. So in some sense, the computer doesn't know either. So we don't know what the y coordinate of this point is. But what we do know is we do know the y coordinate of this point, that if I make x equal to 49, this blue point, I know the exact y coordinate. If the x coordinate is 49, then the y coordinate is definitely 7. Okay, so the idea is I'm going to use that. And so I guess in a very rough sense, I could say, well, the square root, since those points are so close together, I could go ahead and say the square root of 50 is about 7, because, you know, the red point is about the same as the blue point. And so saying the square root of 50 was about 7, that would be correct. I mean, we all agree probably the square root of 50 should be about 7. So without doing anything, we have this basic approximation. But if we use calculus, we can do even better than that. So here's what we're going to do with calculus. Is we're going to use calculus, and we're going to find the tangent line. So there, that green tangent line, that's the tangent line at the point that I know. So I know that point exactly, and I know calculus, so I think I can find the equation for that green tangent line. And then what I'll do is then I will put 50 into the formula for that green tangent line. So that green little dot that you see there, that is a point that's on the line where x is equal to 50. So maybe I'll zoom in a little bit here so we can see a little bit better. And so what's the point of that green, or what's the significance of that green dot? Well, let's go ahead and put up the red dot again, because the red dot was our target. So remember, the red dot was our target. We wanted to know the coordinates of that red dot, but it was too hard. You know, finding the y, in order to find the y coordinate of that red dot, I would have to know what the square root of 50 is, and I don't know what the square root of 50 is. But now let's put up the green dot. Well, wait a minute, you can't even tell the difference. I mean, I guess if I zoomed in for like an hour, you maybe could see a difference. Yeah, I guess maybe, yeah, you're just starting to see a difference there. Okay, so but you see what I mean? I had to zoom in super far. So the moral is that the red dot that we want and the green dot that I think we can figure out. So I claim that we can easily figure out the x and the y coordinates of that green dot. Without a computer, without a calculator. We know the x coordinate is 50, and since it's on a line, we can figure out the y coordinate really easy, because lines are easy. So the point here, the moral here is that the red dot is what we want, but it's too hard. And the green dot we can find, because the green dot is just on a line. And basically, the green dot and the red dot they're practically the same. You know, they're super close together. In order to detect any difference, we had to zoom in. We had to get it under a microscope to see that they were different. So that's the whole idea. And so that's what we wanted. That's the strategy. So forget formulas, forget memorizing meaningless formulas. Just carry out the plan that we've put in place here. So let's review. What was that plan? The plan was to find a point that we know that's close to the one that we want. So the red dot was the one that we want, but we don't know about the red dot. But okay, but the blue dot we know everything about. And the blue dot's pretty close to the red dot. And so then the next step of the plan was to find the tangent line at the blue dot. So since I know everything about the blue dot and I know calculus, I think I can find the tangent line at that blue dot. So let's go ahead and do that. So let's see here. So what have we got? So we need the tangent line, we need a point, and that's no problem. The point we know is 49.7. Oops. And then we need to know the slope. So again, what am I doing here? I'm trying to find the equation of that green line, and it's a tangent line. So to find the slope, I need the derivative. So I need the derivative of the f of x, and I need to plug 49 into that. So, right, because the function is f of x, and so this is the tangent line to f of x at x is equal to 49. So the slope is f prime of 49, and let's see, well, f prime of x, so f of x is the square root function, and so f prime of x is 1 over 2 times the square root of x. So that means that this will be 1 over 2 times the square root of 49, which is equal to 1 over 14. So, okay, so we've got a point on our tangent line, and we got the slope of our tangent line. So, all right, so our green tangent line is, let's see, it's don't tell me, y minus 7. I'm going to write it in point slope form. So y minus 7 is equal to the slope, which is 1 over 14 times x minus 49. And if I wanted to, I could go ahead and solve this for y. So y is equal to 1 over 14 times x minus 49 plus 7. And actually, if you stare at this, this actually is the same remember the formula that I erased? The formula that I erased at the beginning of the video, this is it. If you plug a is equal to 49 into that formula that I erased, you'll get exactly this. So what I'm doing is no different than using the formula. The only difference is I actually know what I'm doing here. I'm not using some meaningless formula that's just a bunch of letters. I'm saying, oh yeah, this is the tangent line that I can find using what I know about calculus. Okay, so now we found the tangent line, and then what were we supposed to do with the tangent line? Oh yeah, we were supposed to put x equals 50 into it. So, all right, so I'm just going to put 50 into this in for x. So I'm going to put 50 in for x. So if I put 50 in for x, then what I get is I get 1 over 14 times 1 plus 7. And so anyway, and that I claim that's the answer. That's the y coordinate of that green point. So the y coordinate of that green point is exactly this, because we plugged x equals 50. This is the equation for the green line, and we plugged x equals 50 into this equation, so we're going to get the y coordinate out. So this is the y coordinate of that green point. And like we said at the beginning, the y coordinate of the green point is basically the same as the y coordinate of the red point, which is what we wanted. So the moral here is that what we wanted was the square root of 50. But what we got was this green thing, and they're pretty much the same. As you can see from the picture, they're pretty much the same thing. And so that's our linear approximation. And so you could figure this out without a calculator, right? You know, because this is just basic addition and division. So yeah, you might have to do long division here because it does say it wants 4 decimal places. So if you know, at this point I probably would use a calculator, but just for pretend, if I didn't have a calculator, I could totally get this to 4 decimal places. I would just have to do a little bit of long division, but that doesn't scare me too much. So that's how you do these problems. So these problems are really just about tangent lines.